Can an AI learn to navigate our world, not by actually interacting with it, but by dreaming about it? I know, it sounds like something straight out of science fiction, but it's actually at the absolute cutting edge of artificial intelligence. So let's dive into this incredible concept of world models. To really get why this is such a game changer, we first have to ask ourselves, what's AI's biggest blind spot right now? I mean, we've got these large language models that can write poetry, they can write code, but they often stumble on a skill that is just fundamental to us humans, predicting what's going to happen next in the real world. They can guess the next word in a sentence, sure, but they can't predict where a ball is going to land. You see, the AI models we have today are masters of the data they've already seen, but they're kind of trapped, bounded by what some researchers call an invisible wall of their training data. They can get stuck with old, outdated information, and they just can't quite grasp the dynamic, always changing physics of the real world. They react to things, but they don't truly anticipate them. And the real world, it demands foresight. It requires a deep understanding of cause and effect. So how do we break through that wall? Well, this is exactly where the idea of a world model comes into play. The answer, it turns out, is to give the AI an imagination, a kind of internal mind's eye that lets it simulate the world all by itself. Think about a professional baseball player for a second. There is no way they have time to consciously sit there and calculate the trajectory of a 100-mile-per-hour fastball. It's just not possible. Instead, they rely on this instinctive internal model of physics that predicts, in a split second, where that ball is going to be. Their muscles just react to that prediction. That is the kind of foresight we want to give to an AI. Now, what's really cool about this diagram here is that it's actually from a comic book from the 90s, explaining how we perceive reality. And you know what? It perfectly illustrates what AI researchers are building today. An agent perceives the world. It uses a model network to process everything and predict outcomes, and then a control network decides what to do. That middle part, that model network, that's what we call a world model. So to put it simply, a world model is an AI's own internal simulator. It's this compressed, abstract understanding of its environment. And here's the key, it doesn't need to be perfect or look photorealistic, not at all. It just needs to capture the essential dynamics of that world, which allows the AI to play out thousands, even millions, of future scenarios entirely inside its own mind. Okay, so how in the world do you actually build one of these artificial dreams? Well, the engineering is definitely complex, but the whole concept breaks down into 3 components that are surprisingly intuitive. First, the AI has to perceive reality. A vision model looks at something complex, like a screen from a video game, and squishes it down into a tiny, abstract summary of just the key information. Think of it as like the digital essence of the scene. Second, it predicts the future. A memory model takes that little summary and a potential action like turn left, and it imagines what the next scene is going to look like. And finally, it decides and acts. A really small, simple controller model looks at the current reality and that imagined future and just picks the best action to take. And now we get to the most mind-blowing part of this whole thing. Because these models are so efficient, an AI can learn a really complex task entirely inside its own simulated dream, without ever having to interact with the real world during its training. Okay, just look at this example from the game car racing. On the left, you've got the actual game screen. On the right, that's the AI's internal reconstruction. Notice how it's all fuzzy and abstract? It doesn't waste any resources on perfect graphics. It just captures the stuff that matters: the track, where the car is, and the upcoming curves. And we see the exact same thing here with the game VizDoom. The AI's internal dream on the right is this kind of ghostly, simplified version of reality, but it's got all the information it needs for the task at hand, like, avoiding those fireballs from enemies. And here it is, the incredible takeaway. Researchers trained an agent to play these games only inside these fuzzy, dreamlike simulations. The AI never even saw the real game while it was training. And then, when they took that learned policy and dropped it back into the real environment, it worked. It worked flawlessly. So how well did it work? Well, in the car racing game, the task is considered solved if you get an average score of 900. The world model agent scored 906. That's a new state-of-the-art result that completely blew past the previous methods. But look, this isn't just about getting high scores in video games. The ability to learn inside a safe, simulated world has enormous, and I mean enormous, real-world applications. So let's take a look at how this concept is already shaping the tech all around us. World models are already out there, being used to train safer self-driving cars, letting an AI imagine millions of potential traffic scenarios without ever putting a real car at risk. They're helping robots in factories learn how to handle new objects without all the costly and slow real-world trial and error. This tech is even being used to generate more realistic video and to optimize super complex systems like 6G wireless networks. The ability to simulate is just a massive boost for efficiency and, most importantly, for safety. So, what does the road ahead look like for world models? Well, the potential is immense, but as you can probably guess, the challenges are just as significant. On one hand, the promise is crystal clear. An AI that can plan, that can learn with incredible efficiency, and that can train safely in virtual worlds. But there are perils. The decision-making process can become a black box, making it really hard for us to understand why it did what it did. Agents can actually learn to cheat or exploit weird glitches in their dream world that don't exist in reality. And right now, we don't really have unified standards for testing and comparing these models. And that brings us to a final, pretty powerful question. We've literally created agents that can learn new skills by dreaming about their world. This fundamentally changes how we think about training artificial intelligence. So the big question we're all left with is this. If an AI can learn by dreaming, what will it imagine next?